Page 529, lesson 8.8 is on factoring by grouping. So factoring by grouping, this is another method for factoring depending on what our situation is. And with factoring by grouping, once we've made sure we've combined any like terms together, we are going to have 4 terms. So we've done some factoring. A lot of it had 3 terms. We talked about in the last section a difference of squares that only had 2 terms that we could factor. This section we actually have 4 terms. So if you look at problem 1, basically what we're doing for factoring by grouping is we are grouping together sets of terms. So on this problem, if you group the first 2 terms together and the last 2 terms together, and then what we're going to do is find the greatest common factor. So the first 2 terms, greatest common factor is 3n squared, and that leaves us with n minus 4. And for factoring by grouping to work, then the stuff in the parentheses has to be the same for both of them. So I'm automatically going to put an n minus 4 on the second parentheses and then think about what would my GCF be that would make that work. And the answer would be 2. If it doesn't work, then I can't factor by grouping. So what happens at that point is when we get to here, if you'll notice, both of these, this is a little different look maybe than what we're used to seeing, but both of these have n minus 4 factors. So now it's like, let's factor out an n minus 4, and I would kind of do this backwards maybe from what the book is. They both have an n minus 4, and then what do we have left? Well, for the first one we have 3n squared left, and then for the second one we have a 2 left. So whichever way you want to put that, those are the same, but that would be our answer to that problem. And like the book's talking about here, you can check that by distributing that out or foiling that out, and then make sure that you get the same thing that you started with. So let's look at the got at 1. They're asking us to factor this. So same idea, we're just going to pair these up. So I'll just pair up the first 2 and the last 2 again. Probably makes it easier potentially if you have this in standard form, where you've got the highest exponents down to the lowest exponents before you get started. And again, always make sure also that there are no like terms that could be combined that we forgot about. So with the first 2 terms, with the numbers, those have a 2 in common, and with the variables, those have a t squared in common. And then in the parentheses, to get back to what we had originally, we know 2 times 4 is 8, t squared times t is t cubed. And then for the second part here, we know 2 times 7 is 14, and we've already got the t squared. So like I mentioned earlier, for the factoring by grouping to work then, what's in the parentheses has to be the same. So I'm not even going to mess around with figuring out necessarily what the GCF here is here. I'm just going to say it's got to be another 4t plus 7 if this is going to work, and then that makes it easier for us to figure out what the number in front would be. So what that means is, to make this work, think about what times 4 equals 20, and that would be a 5. And then also for the other part, 5 times 7 is 35. And the variable parts are all good as well. Once we've got to that point, we can say both of these have a 4t plus 7 factor in common. And if we factor that out, we'll be left with 2t squared for the first one and a 5 for the second one. And this will be our answer. For problem 2, it just talks about that we want to try to factor out the greatest common factor first. Technically, it could factor without doing that, but it's not going to be considered to be factored all the way. It's not going to be like full credit on our problem if we don't factor out the GCF first. Also, it'll give you smaller numbers and things, and it'll make it easier for you to factor the rest. So on problem 2, if you look at those numbers, all those have a 4 in common. And then if you look at the variables, all of them have at least a q. So we can factor out a 4q like they're doing here. And then now that they've done that, now we can go into our factoring by grouping. So first 2 terms have a q squared in common, leaves us with q minus 2. So for that second set, I know it's got to be a q minus 2 for this to work. And to get that to work, we need a 3 in common. And then at that point, again, I would have these switched around from what the book does, but whatever. That would be your factored answer for that problem. One thing just to mention here, notice this has still a q squared in it. Just watch out for, like in the parentheses, if that would have been a q squared minus 4 or something, that would still be a difference of squares that we could still continue to factor further. So some of the problems may continue on past, just doing the factoring by grouping. So on the got it, they went the factored form for this polynomial, and it says factor completely, which means, in other words, you've got to for sure have the GCF and everything, or it's not full credit. So to start with, look at the numbers. With the numbers, we have a 3 in common. With the variables, all of these have at least an h. So we're going to factor out a 3h. So in the parentheses, we'd be left with 2h cubed plus 3h squared plus 4h plus 6. And now we're ready to factor by grouping. The 3h is just going to stay out in front, and then we're going to group these up. So the first set, the numbers don't have anything in common. You can say a 1 if you want. They do have an h squared in common. If you want to make this a bracket here, you can, rather than parentheses. And then if we do that, that'll leave us with 2h plus 3. So we know for this to work, this has to also be a 2h plus 3. So this does work if we put a 2 in front of that. If you distribute, that would give us the 4h plus 6 that we need. So we have 3h out in front, and then out of these, we're going to say they both have a 2h plus 3. If we factor 2h plus 3 from both of those, that'll leave us with an h squared and plus 2. So this would be our factored form for that problem. The next part talks about that we can sometimes factor to find expressions for length, width, and height of rectangular prisms. So for problem 3, they've given us the volume of this toy. This toy you might have seen before. It's called a Jacob's ladder. So this volume, we know volume of a rectangular prism is length times width times height. So something times something times something. So we can try to factor this to something times something times something, and then we'll be able to figure out what the different dimensions are. So the first thing they did is there was a GCF of x. And then this one now actually only has 3 terms left there. And so you could just go ahead and factor it. What the book is doing is they're splitting up that middle term, and then they're doing factoring by grouping. But like I said, if you wanted to, once you got to this point here, you could just say, I'm going to factor that. So I'm going to say 3x times 2x I'm going to try. Everything's positive. And let's try 5 and 3. Nope, don't do it that way because then there'd be a GCF, right? 5 and 3 this way. So there's 9 plus 10 is 19, and it works. Again, you could argue that we kind of lucked into that answer, but it's kind of how they tend to factor a lot of times, and if it doesn't work, we just keep trying until we get what works. So at that point, we don't know what's necessarily the length, the width, and the height, but each of these factors are one of those dimensions of that rectangular prism. So the guide at 3 is pretty much identical, other than the numbers are changed. It's a rectangular prism. What are the dimensions? So basically, we're trying to factor this thing out. So with these numbers, we have a GCF of 2x to start with, which would leave us with 30x squared plus 17x plus 2. And then at this point, we can just try and factor that into two binomials, unless you want to do it the book's way. So to get the 30x squared, closest factors would be 5x and 6x. Not a guarantee, but it seems like it tends to work that way a lot of times. Signs would both be positive, and then factors of 2, we've only got one option, would be 2 and 1. I know I can't put the 2 with the 6 because that would give me a GCF there, so I'm going to put it this way, try 2 and 1, and there's 12 plus 5 is 17, so we got it on the first try. So it says what expressions can represent the dimensions, so it would be 2x, 5x plus 2, and 6x plus 1. So the summary just goes through different things to consider, and these should be on the sheets that I gave you, just considerations. First thing always should be trying to factor out a greatest common factor. And then from there we can just look at other different options. If there's only 2 terms, difference of squares. If it's 3 terms, we're trying to factor it into 2 binomials. If there's 4 terms, then we're going to do factoring by grouping. And then they just mention a final check. Make sure there's no common factors other than 1 in any of your binomials or anything. So if we look on the lesson check, we're going to look at the second part here. Tell whether you would factor the polynomial by grouping and explain your answer. So this first one, we would not factor by grouping because it's not 4 terms. Okay, now again, you could potentially split up that middle term like the book did, but if you don't split it up like that, then we would not do factoring by grouping. Number 6 would be identical answer. It's not 4 terms either. This would be yes. There are 4 terms here. Okay. Now again, it doesn't guarantee that it would work to factor by grouping. I think it actually does, but that would be our method that we would have to try in order to factor that. And then if you look at number 8, can you factor that by grouping? For this one, we're going to actually work this out and make sure if it works or not. So if you look at your first of all, we're going to look for a greatest common factor. So this one, greatest common factor of 1, which we're not going to mess with because that's not going to change anything. So we're just going to go right into our factoring by grouping. So we're going to pair these up. In the first set, we have a 2q squared in common, and that leaves us with 3q plus 1. So if this is going to work, we also need a 3q plus 1 over here. So to get this to work, to get the 12q, we need 4 times 3q. That part's good, but then if you look at this, that would be plus 4, and we need a minus 3. So the actual answer for this is no. We can't factor by grouping, it doesn't work out when we work that out, factoring by grouping. Number 14 we're going to look at just a little bit different than some of them we've looked at so far. We can check it to start, but there is not a greatest common factor. We do have 4 terms, so we're going to go into our factoring by grouping. So the first 2 terms, we've got a 2y squared in common. That would leave us with 7y plus 4. And what that means is over here we need 7y plus 4 in parentheses. So to get that to work, what's different about this is if you look at this, oh, we already have a 7y plus 4. How can we do that? Well, if you multiply it by 1, then that'll give you 7y plus 4. And then if you look at these, we've got a 7y plus 4 factor in common, and that leaves us with 2y squared plus 1. So this gives you an idea of how to factor by grouping.